right, we have a double header today, right? Yeah. So I'm going to let Chloe talk about it all. Thank you, Chloe, for coming.
Okay, hi, I'm Chloe Lund, and my thesis is on highlighting groundwater use by trees in a forested watershed in the Virginia coastal plain. So first we're going to start with just how water moves through the College Woods ecosystem. So it rains, and then the rain is going to infiltrate into the soil column. And any rain that enters the soil column is going to drain really rapidly because the soil is really sandy, so it has a high porosity, which means it's going to drain really quickly. And then right above the water table, the tree roots are going to uptake that water from the soil and then evapotranspire through the leaves, and that happens during the day when the sun is out. Good to take note of that. So we're also going to look at the difference in elevation on the surface versus the water table. So here you can see the tree closest to us in that image. The roots are directly in the stream, so it has direct access to the groundwater, versus up on the hill, it's at a higher elevation, so it is going to be likely above the water table, not using as much groundwater. So why do we care? Trees are using water to execute their functions, to transpire, to photosynthesize, and to maintain the turgor pressure in the leaves, so the leaves don't wilt. And then groundwater use is pretty underrepresented in a humid environment because it's largely assumed that because there's a lot of precipitation, the trees can just use the soil moisture from that. But remember that it's really sandy soil, so any water that enters the column is going to be draining really quickly. Other things, there's implications for buffering forests from drought impacts. So even if there's no precipitation around, like in a drought, groundwater is available to relieve that tree water stress. And if this process is widespread, we'd need to account for it in our water balances. So the groundwater component of evapotranspiration should not be omitted when examining the water cycle. So our research questions are going to kind of guide us through this presentation, and we're going to start with how the top 50 centimeters of soil differs in moisture between sites with shallow versus deep groundwater. And then, do trees use groundwater in college woods? And if so, how much are they using? So I'm going to introduce my sites. Here we have CLBO2 and CLBO1 are about at the 0 elevation. So that's like right by the stream. Whereas the two other ones hit at about 3 and 5 meters above the stream. So just indicating that different elevation. So finding the elevation of the sites was fun. Terry and I went out with the studio rod, if you can see that, and a transit. And looking at the little numbers on that, we were able to find the relative elevations to each other, with the 0 being the stream. Some other tests we did was with soil moisture, and we set up this little contraption at the same elevation as the tree site, and we dug around 50 centimeters and then put in soil moisture probes at 10 centimeters, 25 centimeters, and 50 centimeters. I don't know if that's better. It's better. Okay. 10 centimeters, anyway. So that's continuously logging, and here we can see, so first we're going to look at the sites with shallow groundwater, and this is all the soil moisture data from that. And so at the sites with shallow groundwater, you can see that generally the soil moisture is higher, just as a marker. This doesn't mean hard that it's dry or wet, but at one site it's generally a little drier, but generally shallow groundwater, wetter soil. And then sites with deep groundwater, the soil moisture is generally lower, again, hitting beneath the 0.25 there. And just to really set this, really bring it home, the soil moisture is generally higher at sites with shallow groundwater. So on the left here, on left side of the red, these blue box plots are showing the two shallow locations, shallow groundwater locations. And you can see that they're generally higher, so the soil moisture is higher versus on the other side, generally pretty dry. So how does the top 50 centimeters of soil differ in moisture between sites with shallow versus deep groundwater? The soil moisture at sites with shallow groundwater have generally higher water content than at sites with deeper groundwater. And that's important to note because we want to know like if trees are taking advantage of using this groundwater and if that like leaves a permanent signal that groundwater use is dropping. So do trees use groundwater in the college wood? Are they taking advantage of this? To figure this out, Jenny and I all summer dug holes and installed these groundwater wells with water level loggers logging every 15 minutes continuously from July until January. And this is all of the data and it looks like a lot, but we're going to break it up. So first we're going to just look at August and you see these little fluctuations and we're going to look at them a little closer. So here you see that there are these observed daily fluctuations. It goes down, up daily. And we're going to look back at this a little bit. And then in November, there's nothing. It's just a straight line, give or take. Like there are some fluctuations, but it's not the daily pattern that we see. No observed daily fluctuations. So here, just to really bring it home. So when the sun's out, you see this general decline, and then when the sun's out, and then at night, there's no transpiration happening, so the water is recharging, and this is shown to reflect the transpiration, which happens when there are leaves on the trees. And then in November, there's no leaves, there's no daily fluctuations. It's pretty clear right there. So do trees use groundwater in college woods? Yeah. The daily groundwater fluctuations indicate that trees incorporate the groundwater into their root water uptake. And from that, we want to like look at the signal across the whole thing. So we're going to look at how much water they're using. So how much do trees use groundwater? Allison, I know this is scary for you, but it's okay. So what we're trying to find is the groundwater component to evapotranspiration. And to do that, we're going to look at this property of soil, the specific yield, and take that into account. Looking at the change in groundwater levels, is a change in storage, looking at what time intervals, and then the total groundwater recharge over a 24-hour period. So, yeah, looking at this, the downward slopes indicate the tree using the groundwater for transpiration during the day. And then the upward slopes is the groundwater recharge at night, which is pretty steady because at night the trees are not using the groundwater. So it is purely, mostly, just the recharge data. So first, what we're doing in this equation is we're looking at the change in storage. So you take the data point at the first midnight, and then the data point at the second midnight, and the change in Y is how much the groundwater table dropped. And again, we're looking at that over one day. And then, so here we're taking the data points from midnight to 4 a.m. because that's when the recharge is the most steady, and taking that slope and extending it out, we can set in the Y equals mx plus b, you set the following midnight as the X, and that change in Y again is how much recharge happens, because remember, even though the tree is transpiring, that recharge is going to be constant. So the recharge for this day was 41 millimeters. And yeah, putting that all together, it's a little cut off, that's fine. You add the two up, and then 43 millimeters per day, but only a part of that volume is going to be used for the groundwater evapotranspiration component. So looking at the volume with the 0.27, taking that into account, the groundwater component of evapotranspiration comes out to around 11.6 millimeters per day. So I can't do that for every day for however many months that was. So we were automating the process to calculate the groundwater component of evapotranspiration for each day. And doing that, we get this. So you can see it's pretty variable, but generally you see that evapotranspiration is happening. So it's pretty variable, but you can see it's happening in the summer months, and then when it hits October, it pretty much drops off, which you can see a little clearer here. And again, it's variable, but it's pretty evident that it's happening. So if so, how much water are they using? It depends. So trees are using variable amounts of groundwater. Also depends on like if the sun's out, depends on the time of year and other weather factors like precipitation, wind speed. So just to summarize, how does the top 50 centimeters of soil differ in moisture between sites with shallow versus deep groundwater? So the more soil moisture, there is more soil moisture in shallow groundwater environments, and are trees taking advantage of this? Yes, they are, but how much are they? Depends. And we're going to kind of finish looking at this data for the other wells, because right now we just have this for one well. And again, we have 4 sites, and matching up other factors like aligning with precipitation, seeing where those patterns happen, repeating that for temperature, humidity. You can look at all those things. And I specifically looked at beech trees. You could do this for other tree species and look at more sites just to bring home that pattern. And yeah, thank you guys.